Hey guys, in this video I'm going to talk about freely falling motion. So this is one of the most basic ways that objects can move, freely falling under gravity. So let me get you a quick picture of what I'm talking about here. So literally the diagram is as simple as you can possibly think. I am dropping something, for instance this ball, and I am dropping it down a height, say a height h. So I might not only be dropping it, it's possible I could be throwing it downwards with some initial velocity. But essentially all that's happening is it's moving under the action of gravity, and that's the important point. So if I try to draw a free body diagram for this ball, the free body diagram is going to be quite simple. So I start with the center of mass of the ball, and I think, okay, what forces are acting on the ball? Very clearly, the force of gravity is acting on the ball. But part of the assumption of freely falling motion is that there are no other forces, no drag forces, no other friction forces. So Fg is the only force acting on the ball. So if I want to do Newton's second law on the ball, I want to sum up all the forces. That's going to be my mass times my acceleration. That force is a vector, so I'm going to set a coordinate system x, y like that. And it should be pretty easy to see that first, the sum of the forces in the x direction is 0 because the x direction is like this and my only force is vertical. And the sum of the forces in the y direction is going to be negative mg. Mg because that's the force due to gravity, that's Fg, and the negative sign is in there to give the direction of gravity with respect to the positive direction of the y, which I specified there. So the left-hand side of Newton's second law is negative mg. The right-hand side is may, and I wrote little may, so I know this is the acceleration in the y direction. I could have just left this as ma, but I'm trying to emphasize that we're only talking about the y direction right now. And then if I solve this, the m's go away, and I get simply that the acceleration in the y direction is negative g. Now that I know what the acceleration in the y direction is, I can go back up to my kinematic equations of motion and determine what the position and velocity are as a function of time using this acceleration. So I'm going to do one slight rewriting, which is that when I write these as x and v of x, I'm suggesting obviously that these are happening in the x direction, the horizontal direction, but I want in the vertical direction, so I'm just going to rewrite both these equations, putting y's everywhere. And that looks like that, with just putting, wherever there's an x, I put a y at the exact same equation, but now it looks more like I'm talking about the vertical direction. Okay, so now I know what the acceleration is, and in freely falling motion, the acceleration will always be this, so I can just replace those accelerations with negative g, and I get the equations of motion for an object which is undergoing free fall. There's actually very little difference between this and this. I've just set the acceleration to be negative g and relabeled x's and y's, but this is what I can use anytime I have a freely falling motion problem. I can just go straight to this set of equations and solve them. It is important to remember that when I talk about freely falling motion, I'm not just dropping a ball, I'm possibly throwing a ball downwards. So this velocity right here, this doesn't have to be 0. But other than that, this is exactly like doing any other kinematics problem. These are the two equations fundamentally governing the motion, and how you solve the problem is a matter of figuring out which of these things you know, which of these things you don't know, and coming up with a solution method which is algebraic in nature. Okay, great. So that's an introduction to freely falling motion.